Hello, I'm Emma Sloan. I'm a junior here at UTA in the Department of Geology and Environmental Science. Today, I'll be presenting upon the project of baseflow tempestology in the Gulf of Mexico. Essentially, when hurricanes and tropical cyclones move through the Gulf Coast, we get to see the discharge of water through streams, creeks, tributaries, that kind of thing. So a little bit of prior background knowledge for you, just in case you don't already know. As climate change becomes more prevalent in our everyday world, there's going to be a couple of environments that we get to see are a little more sensitive to these changes, such as the Gulf of Mexico. One of the main changes that we will get to see is that there will be an increased amount of hurricanes as well as more volatile hurricanes. So, what we're doing for this project is by looking at historical data, we get to see how our environments are already handling the major events that are going through them. So how we went about doing this is that we had two steps. Number one, we went to the NOAA databases and we looked at historical data, going all the way back to the 1850s, all the way to last year, to the most up-to-date hurricane data that we have. Basically, we looked at how strong the hurricane was. We only picked hurricanes that are between 3, 4s, and 5s, just so they are major events, and then a few other stipulations. Once we had narrowed down our list, we went to step 2. We went to the USGS database, and then looking at the flow of each hurricane that we had chosen, we found water stations along their path. Going into these water stations, we then looked at the discharge rate of, say, the creek or the river that the water station is on, just to see how fast and how often this water is moving throughout. So when we looked at the particular events, the dates of the hurricane, we went a few days before, just to see like a normal average time in that month, the peak during the hurricane, and then how the water was discharging post the event. Generally, it took a couple of days. As you'll see on our results section, our first big picture is a map of all 149 hurricanes that we decided to use for this particular data set. And then for the other two graphs that we have, the hydrographs, we mostly focused on Hurricane Harvey. Since UTA is in Texas, it's the most prevalent hurricane that's really happened to us to date. What you'll mainly read from these graphs is how the water discharged. As I've been going over, you will see like a normal rate of how the water has been flowing through, how it'll peak with the storm surge, and then how many days it takes for it to flow back out. For instance, for Hurricane Harvey, for the Texas Gulf, it took anywhere between 4 to 9 days for an environment to fully go back to something close to normal. It's a couple of days. So you're probably asking, why? Why is this important? It's pretty important for many different reasons. Number one, as I stated at the very start, we're going to start having more hurricanes. So as we're starting to have more hurricanes, we can see which environments along the Gulf states can better handle hurricanes while others can't. So those who are ecological caretakers know, hey, maybe we should go help that one particular spot be better prepared for the next large event, because there will be another one. Another reason why this research is super important is hurricanes bring in a lot of different types of water, lots of trash and pollutants in it. So we're introducing with large hurricanes a different type of water chemistry than that type of area is used to. Areas that might have endangered species, fragile ecosystems, easily moved debris, and pollutants can really greatly affect the groundwater that'll eventually seep into that area. So there's a lot of different reasons why this research is super important. I hope you found this as exciting and cool as I do. Thank you for listening and have a great day.